In the dynamic landscape of industries relying on maintenance and field services, the concept of a wrench time holds paramount importance. Wrench time refers to the actual time spent on hands-on, value-added work by maintenance personnel, a metric that becomes a cornerstone for efficiency and productivity. In this video, we delve into the significance of wrench time, explore its key elements, and discuss strategies for optimizing it. Wrench time, at its core, encapsulates the productive hours during which maintenance or field service professionals are actively engaged in tasks that contribute directly to the operational efficiency of machinery, equipment, or facilities. This metric acts as a critical performance indicator, reflecting the effectiveness of maintenance teams in executing their responsibilities. To better understand wrench time, let's discuss the relationship between maintenance planning and wrench time. Maintenance planning is a tactical process within the field of maintenance management that involves the systematic preparation and organization of maintenance work with the goal of eliminating wait time, improve coordination among the maintenance and production team prior to the execution of the work. A successful maintenance planning process leads to more time spent by the maintenance workforce on value-added work than to a higher wrench time. Wrench time appear then to be the ultimate measure of planning effectiveness. Organizations measuring wrench time regularly and acting on it will see an improvement in their planning activity and a direct result in their productivity. In many industries, a typical wrench time percentage might range from 25% to 35%. This means that technicians spend only a quarter to a third of their total work hours on actual hands-on maintenance activities, with the rest of the time being consumed by non-productive tasks. Achieving world-class wrench time involves optimizing planning and scheduling processes, minimizing downtime, and streamlining workflows. World-class organizations can achieve wrench time percentages in the range of 50% to 55%. The elements impacting wrench time are usually all-around effective maintenance planning process. Some examples of the manifestation of poor planning processes directly affecting wrench time are materials and parts availability and readiness. Waiting or searching of spare parts once a job has started is a non-value-added task that negatively affects wrench time. Hence, this is one of the major sources of prolonged downtime and maintenance workforce productivity loss. Tools availability. Ensuring that the right tools are readily available when needed is fundamental to maximizing wrench time. Proper planning and tool management systems can prevent delays caused by searching for or waiting on tools. Clear instructions and information. Providing technicians with clear and concise instructions, along with relevant information, minimizes confusion and enhances task efficiency. Training and skill development. Well-trained and skilled personnel are more likely to perform tasks swiftly and accurately, positively impacting wrench time. Let's now discuss how wrench time improves productivity without the need of hiring. We will summarize the approach covered by Doc Palmer in his book, Maintenance Planning and Scheduling Handbook, 4th edition, to show how a wrench time increase can result in increasing the productivity of the workforce without the need to hire more people. Let's consider two scenarios. In Scenario 1, we consider 10 technicians working with ineffective planning function. We assume that each technician spends 40 hours per week at work, and the wrench time of the team is evaluated at 35%. The global productivity can be calculated as 10 technicians at 40 hours per week and 35% of productivity, which equals to 140 man-hours per week. In Scenario 2, we consider one technician out of the 10 technicians is trained to become an efficient planner. We assume that each technician spends 40 hours per week at work, and the wrench time of the team is evaluated at 55%, which is the best-case scenario. The global productivity can be calculated as 1 planner at 40 hours per week and 0% productivity, plus the 9 remaining technicians at 40 hours per week and 55% productivity, which equals to 198 man-hours per week. By converting a technician into a planner, each technician increases their productivity by a ratio of 1.57. A team of 10 technicians then becomes a team of 1 planner and 9 technicians working at a productivity of 1.57, which equals to the productivity of a little over 14 technicians at the 35% wrench time. The application of best practices for planning and scheduling of work makes it possible to transform a team of 10 technicians into a team of 1 planner and 9 technicians, with the productivity of 14 technicians under the same conditions. With the same approach, in a team of 30 technicians, 35% to 55% wrench time transforms the team to the productivity of 47 technicians. In a team of 30 technicians, 25% to 50% wrench time transforms the team to the productivity of 60 technicians, which is a double of productivity. We can conclude that an improvement of wrench time, through effective planning and scheduling, directly increases productivity, which benefits can easily be converted into monetary value. Here are some recommendations to improve wrench time. Application of the best practices of planning and scheduling. Effective planning and scheduling are crucial for optimizing resources, improving efficiency, minimizing downtime, and improve wrench time. Implementation of a feedback loop through effective end-of-work report. The end-of-work report serves as a means of communication between the technicians and the planning team to provide feedback about what went well and what needs to be improved. This feedback is important to avoid the same errors to be reproduced and enable a continuous improvement culture in the maintenance team in general and the planning team specifically. Efficiently use of CMS and promotion of proactive culture over reactive culture. The constant promotion of proactive culture will boost efficiency by having the maintenance organization assess and improve himself on various aspects such as training and skills development, risk assessment, condition monitoring, root cause analysis, performance monitoring, and communication and collaboration. In the realm of maintenance and field services, wrench time emerges as a metric that transcends mere operational efficiency. It becomes a measure of an organization's ability to adapt, plan, and execute effectively. As industries evolve, optimizing wrench time remains a constant pursuit, requiring a holistic approach that encompasses planning, technology, and a commitment to continuous improvement. By recognizing the pivotal role of wrench time and implementing strategies to enhance it, organizations can unlock new levels of productivity and resilience in an ever-changing landscape.